Good morning and afternoon, Matt 2 crew. This is a review for the upcoming quiz on powers and their properties, simplifying them, writing them in radical form, and also polynomials, multiplying binomials, and also adding and subtracting polynomials. So I would recommend that you really focus on this video. These questions are identical to what you'll see on the quiz. So this is my way of providing you with access to information that you must know by tomorrow. So pay attention, focus, concentrate, and you'll do just fine tomorrow. So question 4, found on page 365 and 366. Again, these questions are from your textbook, 365 and 366. What is the simplified form of 8 to the negative 1/3 power? All right, so what we would do here is, first of all, write the question down. Now, you might remember that the negative exponent takes the original power and rewrites it as the reciprocal. And so 1/3, we know that would be the third root of 8, right? If I were to go one step further, if you didn't know that, this would be the third root of 8. And of course, 8 is 4 times 2, and 2 times 2. So looking at our factor tree, 8 could be represented as 2 to the 3rd power, right? And if I were to go one step further, you would see that the 3rd root and the 3rd power are inverses of each other, which gives us an answer of 1/2. Again, that could have been done at this step here with the factor tree. You could have easily done this as well. Rewritten 8 as 2 to the 3rd raised to the 1/3 power. And we could see here that those powers, of course, reduce each other to 1, and 2 to the 1st power is, of course, 2, which gives us 1/2. Next question. What is the 3rd root of a squared in rational exponent form? Well, just recall that our pattern from changing radicals to fractional powers this. Right? Where the root is the denominator of your fractional power and the power of the exponent is the numerator. So knowing that, I could see that our value for A here would be 3. Our value for B would be 2, right? See that? B, and A. And so rewriting this would give us this expression here equal to that. And if I were to write it so that you would see the whole expression written as an equality, I'll give you a highlight here. And again, it follows this pattern here. Okay, so the answer looks like it is B. Moving on. Sue began simplifying the expression, okay, by writing the expression. What is the next step she should take? Again, I didn't read the whole thing, but of course you can. And so what is the next step? So let's write the steps out first of all. Okay, so here's what she has. Looks like she's trying to simplify the expression, right? So radical x multiplied by the 4th root of x. And so we learned several weeks ago that radicals are sometimes difficult to simplify, but when you write them as fractional powers, they become just like simplifying fractions, right? And we can do that. So the square root is 1/2 power, right? And the 4th root is the 1/4 power. And multiplying powers with the same base, we know that we add the exponents. Yeah, that's the trick there. So we're going to take this expression, and we wrote about this too in our for our first writing task. So we're going to add the exponents and keep the base. Right? So that would be the next step here. Now, do we see that anywhere? This is the next step. It's not simplified yet, but that is the next step. So let's see, right? X to the 1/2 power. Nope, that's not it. Looks like it's h. Would be this one here. Okay. Moving on. About halfway done. What is a radical x to the 5th times the 3rd root of x squared in simplified radical form? Your answer must be in radical form. Okay. So let's change this as a fractional power and then convert it back to radical form. So in my rules, and I don't need that multiplication symbol there. We should know by now that we're multiplying. Okay, write these as fractional powers. Okay, remember this is square root, so there's a hidden 2, right? That's 5/2. And this would be 2/3. Common denominator is 6. Okay? So remember, I'm going to add these up. So I guess I'll write the step out before I... So in order to add the exponents, we've got to have a common denominator, which is 6, and multiply this by 2. And middle school math is coming in handy here. So we end up with 15/6 plus 4/6. Adding those together gives us 19/6. Now you will make a mistake if you think that this is the answer. It clearly says in radical form, so rewriting this in radical form, okay, the denominator is the root, and the numerator is the power, or the exponent of the power. And there we go. So it's letter D. This is your answer. Okay, next question. What is a simplified form of this expression? All right, so we have to distribute the power. Remember, when you raise a power to a power, you've got to multiply through. So let's rewrite this expression. Okay. Now, I also remember that anytime I have a number and I'm dealing with powers that are in fractional form, I always want to write that number in its power form. So when I look at 16, I know that 16 is 4 times 4, or 2 times 2 times 2 times 2. So that would be 2 to the 4th. So I'm going to write 16 as 2 to the 4th. Right? So here we go. So I'm going to distribute. Okay, 2 to the 4th is 16. Now I'm going to distribute 3 halves. Right? And then we have 8 to the 8th, and I'm going to distribute 3 halves. Alright, so 4 and 3 halves. Remember, when you multiply a power to a power, you multiply. And 4 over 1 is still 4, and 3 halves. I just want to show this so that those who are still struggling with this concept. Multiply straight across, you get 12 over 2, or you can cross reduce, which gives you 2 times 3, which is 6 over 1, or just 6. So, it's just 6. You can see that here too. I like to keep everything within this field of work. And so 2 times 3 is 6, so it's 2 to the 6th power. Here, same idea. That got mumbled there, so 2 there. Cross that off, this becomes 4. And then 4 times 3 is 12. This is a to the 12. And so 2 times 2 times 2 times 2 times 2 is going to be 64. So my answer is 64 a to the 12. And again, 2 to the 6th power is 64. Check it out. So that's my answer, and we can see that my answer here is J. Moving on, moving quickly. Okay, this is an open-ended question. It's not a multiple-choice question, so we've seen something similar to this. So we're just asking to fill in the blank blue spot. So complete the simplification in the product. Okay, it tells us here to write the radicals in rational exponent form. So I can do that. This is 1/2. This is 1/6. The product property of powers, we've talked about that, where you have the same base, so you add the exponents. Then it says simplify the exponent, so our common denominator is 6. So if I was to simplify it, I'm going to do the work over here for you, okay? 1/2 plus 1/6. Let's multiply this by 3. So that'd be 3 over 6. Let's cross that off. Which gives us 4/6, right? And 4 over 6 simplified is what? 2/3. Okay? So this becomes 2/3. And that's going to simplify it. So I cross that off and write it as 2/3. And then write it in radical form. Again, your denominator is the root. The exponent is the numerator. And this is the simplified radical form of the original expression here. Okay, next question. Now here we're talking about polynomials and we're multiplying them. So this is what is the product of these two binomials. So you could use generic rectangles, distributive property, FOIL method, whatever works for you. Use the technique that makes sense. So I'll show every single step. Okay, so I'm going to multiply through. That is 2x times 3x plus 2x times 5 plus negative 9 times 3x plus negative 9 times positive 5. Okay, let's clean this up. We get 6x squared plus 10x plus negative 27x plus negative 45. Okay, let's combine like terms. It's just negative 17. And I've said this before. This is identical to this expression here. When you add a negative number, it's identical to subtracting that quantity. This is your answer. Looks like the answer is going to be A. Barring no mistakes. Again, I make mistakes. Check my work, please. Next question. What is the standard form of this polynomial? Remember, standard form, you write the powers from greatest to least. Again, what's this mean? Powers from greatest to least. Remember that. So in order to do that, though, we've got to subtract these two polynomials. So I talked about this, where you take this subtraction sign, you make it a positive sign, and you distribute that negative sign to each of the terms And so you can see that these become opposite in sign. See that? This is 8, that's negative 8, minus 5, positive 5, plus 9, minus 9. And then this expression here. If you like, we can use the vertical technique. But I think I'm just going to bring it down and then combine them by grouping. So x squared, those are like terms, 5x, and your constant. Okay, so I would group these. I forgot to put my equal sign. Good. Just regroup them. And that's our answer. So, looks like the answer is H. Yeah, okay. And the last question says, given the functions p of x and q of x, find the sum p of x plus q of x, and also the difference q of x minus p of x minus q of x. So we can do this. So let's do the addition first. So we're going to substitute with p of x. Okay, p of x is this expression right here, and it is equal to that. So we substitute. So that's my first step. So I'll write that down. We're going to add that to q of x, which is this expression. Okay? Now, since there are no negative signs in terms of subtracting these amounts, this positive sign just means that, hey, we're going to group these together, and we're going to add them. So we don't have to change the sign of anything. So I'm going to look for my common I like terms so I can combine them. So the 3x to the third power is the only one. So I cross that off and bring it down and write this in standard form. The x squared term is here. Okay. Okay, now look, they're opposites of each other. So we can just, since we're adding them, we can cross those off and they go away. Okay. Now, and then I look for my x terms, and there's only one single x term right here. So, and you're adding that, so it's plus 4x. Then we look for our constants, and then we have 7 and 10, and we're adding those together, gives us 17. And so this is our answer, 3x to the third power plus 4x plus 17. Okay, so that's p of x plus q of x. Now, what about p of x minus q of x? All right, well, let's see what that looks like. So I'll write this out. This is p of x So let's distribute the negative sign. Okay, and we know that that's going to give us, okay, so I'll bring this down here. This changes it to plus, right? We talked about that. This now is an addition sign. This is now negative 4x minus 10 minus 4x to the second power. So grouping things together, for the sake of time, I will group them by just highlighting and then working this out. Okay, and forgot to put the 3 there. So give myself some space. Okay, and here we go. So the x squared terms combine. Negative 4x minus 4x squared, right? See the 4x squared, so that gives negative 8x squared minus 4x. Just cross these off here so that I don't lose track of what I've already done. Minus 4x. And 7 minus 10 is negative 3, or minus 3. And that is our answer. Okay, study hard and learn a lot. Again, this information is on the quiz. Know it. Study it tonight. You'll do well tomorrow. We'll see you soon. Bye-bye.